Today we're looking at piecewise functions. So your essential question is, how do I work with piecewise functions? Your learning intention: I'm learning to write, graph, and use piecewise functions to solve real-world problems. Your warm-up: find the x and y intercepts and graph the following equations. You've got the equation, you find the x and y, and then graph it. So pause the video now and see if you can do that on your own. Well, I do hope you tried. So if we're looking for the x-intercept, that is where y is equal to 0. 3x minus 6 times 0 is equal to 18. 3x is equal to 18. Divide by 3, and x is equal to 6. So one point will be 6, 0. For the y-intercept, that's where x is equal to 0. So 3 times 0 minus 6y is equal to 18. Negative 6y is equal to 18. Divide by negative 6, and y is equal to negative 3. So this is 0, negative 3. You now have the 2 points you need, and you can graph. Okay, I hope you were able to complete that on your own, and we're only checking your answers. Okay, so what are we talking about today? Piecewise functions. What is a piecewise function? Well, a piecewise function is a function that has different rules for different intervals of its domain. These intervals must be distinct because a function cannot produce two different f of x values for the same x value. So this is piecewise functions. If you think about the word itself, it's got piece in it, which would lead you to think of different pieces of a graph. So if we're looking at how they apply, a deep farmhouse sink is slowly being filled with water at a rate of 2 gallons per minute. After 4 minutes, the stopper accidentally comes loose, and over the next 2 minutes, the volume decreases by 15 quarts. Once the stopper is properly put back in, the water fills the tank at a rate of 3 gallons per minute to fill the sink to a capacity of 22 gallons. What is the domain of this function? Okay, if we're looking at it, what are my x values? I go from 0 to 22. So 0 is less than or equal to x, which is less than or equal to 22. As interval notations, that would be 0, 22. You notice they have the brackets because those are closed circles. The 0 is included and the 22 is included in the domain. What about the range? What y values are we looking at? We start at 0 and we go up to 22 gallons. So 0 is less than or equal to y is less than or equal to 22. Once again, it will be 0, 22. If I'm looking at this, it looks like our x values might go past 22. I think it goes up to 24 here. So I'm going to change that to 24. Might be just a little bit off. But for this example, either one will work. Okay, so as we're looking at, where is this graph increasing? You notice between 0 and 4 minutes. And then again between 6 minutes and 12 minutes. Between 0 and 4 minutes. And between 6 minutes and 12 minutes. Okay, what about decreasing? If we're looking at where is it decreasing? Well, it's decreasing clear over at this edge. Between 20 and 24 minutes. How would you talk about what was actually happening there? Why is it decreasing? Why is the number of gallons of water going down? The sink is being drained. Why would it be increasing? What are we doing there? We're filling the sink. Okay, so we're filling it up and then it goes down. We forgot about that little spot there that the stopper came undone. That would be a decreasing slope. And this is between 4 and 6 minutes. What happened there? That was where the stopper came loose and it let water out. Okay, so what would this flat area up here be? If I'm looking at that flat area, that's where they were using the sink and had it full of water. Okay, now we're getting into the graphing part. If you notice, you are given different domains. The first domain we're looking at is if x is less than -3. So -3 is this spot right here on my x-axis. That's what it corresponds to. So before -3, we have -2x. -2x means that I'm going to, it'll start here, and if I go over 1, up 1, over 1, over 1, up 1. So if I go over 2, I go up 2. If I go over 3, I'm going to go up to 3. So this would actually go across, this would intersect the origin of your graph. So this part would be when x is -3, -2 times -3 is +6. So when x is -3, y will be +6. Is it equal to? No. That means I've got that open circle. Now what do I do? Well, it's that negative slope of -2. So if I would usually go down 2 and right 1. But this time I will go up 2, and then I will go left 1. And that will give me that negative slope. I need to go over to the 4 there. Now I am ready to graph. If you notice, it has to stop. It doesn't go all the way down. It stops right here. This is that first part. Okay, now, next we're going to look between -3 and 2. For this part of the graph, here's -3 and up to 2. This is the part we're looking at now. 3x plus 1. So I know that I start at 1, and then I go, here's my first point, and then I go up 1, 2, 3, and right 1. There would be my second point. But I only start at -3. So I've still got to do more points. Okay, so this is where I'm actually going to start, because this is -3. I could have put -3 in here. -3 times 3 is -9, plus 1 is -8. So the starting point is -3, -8. This time it is equal to, so this will be a solid dot, and I go up to 2. 3 times 2 is 6, plus 1 is 7. This time this will be an open circle because it is not equal to. Draw your line. It's actually a line segment. So to find your first point, you're going to substitute in -3. So we've got 3 times -3 plus 1 gives me -9 plus 1, which is 8. So I start at -3, 8. My ending point is when x is equal to 2. So I have 3 times 2 plus 1 gives me 6 plus 1 is 7. This point is 2, 7. So my ending point, my beginning point is -3, 8. My ending point is 2, 7. So if we're looking at the next one, this time we actually start at being greater than 2. Greater than or equal to 2. So now I'm going to go from here on out. I use x minus 1. So when x is equal to 2, 2 minus 1 is 1. So this is a point 2, 1 to begin. Now at this time it is a closed circle because it is equal to. I'm going to have to use my slope of 1 to find my next dot. So I go up 1 and right 1, up 1, right 1. Now this one will go on forever. And as you notice, you find you plug the first and the last x values in to find your first and last points, You put the x value in to find your beginning point. This one was actually the ending point, but we had to have somewhere to begin so that we could find the next point using the slope. There's a special kind of function that is a piecewise function that is constant over each interval of the domain. Okay, this is what we call a step function. Okay, so the step function is an example of the step function is the, okay, what do you think goes in there? And it's called the greatest integer function. Okay, so which rounds the number x down to the greatest integer that is less than x. So if we're looking at these, if you notice they start at one and end at the next. So to do all of them, we would have to be able to go on forever, and we don't do that. So we use those little dots to tell us that it goes in the same way in both directions, both before and after. This is a graph of the greatest integer function, and we're going to do the domain for -2 up to +2. So as we're looking at -2, -2 goes from here to here. It is from -2, but it ends at -1, starts at -2, ends at -1. It is equal to -2, but not equal to -1. So -2 is less than or equal to x is less than -1. So what about the next one? We're looking at -1. Once again, it goes up to 0, but does not include 0. So it's -1 is less than or equal to x is less than 0. Look at the pattern. Do you know what comes next? 0 is less than or equal to x is less than +1. Now do you have the pattern? 1 is less than or equal to x is less than 2. Write the last one. I'm going to wait for you to write that last one. What does it look like? 2 is less than or equal to x is less than 3. And we could go on doing that forever. So if you're looking, and this is actually the equation for it. So if you're looking at piecewise functions, it means that different things go on in different parts of the function. And just like filling a sink with water, there's other real-life examples that you can find. So these are all piecewise functions. They would be an example of a discrete function.